Okay. You can see the screen, right?
Yes, sir.
Yes.
Okay. And when time, 2:40 class is end, just remind me before 5 minutes. Okay.
Okay, sir.
Pressure vessel, you will see around might be in your home. Okay. For example, in car, we use pressure vessel, gas cylinder, CNG cylinder. Then in your home might be we cook with LNG or LPG, whatever the fluid we use in a cylinder. So that is also pressure vessel. Then boiler is also pressure vessel. Then submarine is also pressure vessel. So all those things you need to make sure that it will not burst while in working. Say you are working in a LNG company. They are selling LNG in a gas in a cylinder. Is pressurized. Say pressure is 400 psi. So you need to make sure that cylinder you are making with the material, that material able to carry that much load, and it will not burst. Say you are working for Bangladesh Oxygen Limited to carry the oxygen cylinder. Now we design the cylinder. You say pressure inside the cylinder will be 60 psi, and you supply to the hospital and it burst, then 10 patients died. So you design something to save people life, but due to your mistake, people died, right? So it is extremely important to design a product and with safely. That means you need to make sure that your product will not be failed during operation. Normally in our country, nothing happened. Say you design a pressure vessel or gas cylinder, is explode, 5 passengers died in a car or bus. So you have money, you pay money under the table, nothing will be happen. But in other country, your company will be liable. They will sue the company. For example, you design a car with faulty design, and due to your faulty design, the accident happened and people die. Then the people will sue the company, and company has to pay the compensation. Then company will look for the engineer who designed that parts. Okay, so this is very important. So in this slide, you see a submarine. Submarine is also a pressure vessel, because when it go under water, say under depth of 2 miles, say this is surface of the sea. So how much will be pressure of the right over here? P equal to H rho G. Similarly, some pressure will be over here. Around the wall surface, there will be pressure perpendicular to the surface. Then inside also will be pressure, little bit, about close to atmospheric pressure. So you need to make sure that you design a submarine, supply it to other country to carry the soldier under the sea of 2 miles. You need to make sure it is not get squeezed due to the water pressure. Similarly, you see a boiler, you need to make sure boiler is not getting burst while it is operating. And normally in Bangladesh, you will see a lot of boiler explosion in the rice mill, also in the garments factory. It gets explode and people die, right? So this is very important. Now, you see a airplane in the construction phase. You see the inside of this plane. There is a little beam over here, frame, a round shape. Okay, that is usually analyzed with like a beam. Then you see some structure going from forward to aft. Those structure work like a beam. Okay, and the outside you see this is called, normally they call it skin, but it's actually aluminum plate, thin plate. Now, why showing the aircraft over here? When aircraft fly, this window covered by solid glass or acrylite sheet, you cannot open this window, roll down or roll up. You cannot do it. And when passenger get in the inside the aircraft, when it take off, the door is completely sealed. That means airtight. Okay, so and inside the airplane is also pressurized. Even if you fly first time in the aircraft, finally you can realize when you say is take off from the airport, say at certain degree, then this is altitude, that means height from the ground gradually increasing, you will feel some pressure inside in the air, because in human body inside you have some pressure about 14.7 psi, but at 40,000 or 35,000 feet above from the ground level, pressure is low. So in human body inside the aircraft, inside your stomach pressure is 14.7 psi. Outside is low. Then what will happen? Your nose, blood will come out through nose and eye. So that's why what pilot they do, they increase the pressure inside the aircraft. So whole aircraft work like a pressure vessel. And a lot of time, if you see some newspaper, you might see that some airline plane is crashed or they land emergency landing. They have emergency landing because of some skin, or they call it panel, is come out from the aircraft. Okay. So in every case, whatever example I'm showing over here is very important to make sure that you design a aircraft, you design a submarine, you design a special vessel that is safe to use and it will not fail. Now, pressure vessel normally in terms of thickness of the wall, the two types is called thin wall pressure vessel. Another one is called thick wall pressure vessel. So this one is thin wall pressure vessel, and this is thick wall pressure vessel. Thin and thick. So like column, we have a short column, then we have a long column, right? Sometimes you see your column is very thin. Sometimes you might see column is a very fat or very strong cross section, but it behave like a long column. Again, a very short column might behave like a, you see very short or very slim, but behave like a long column. Again, a long column, it might behave like a short column. How will figure out? By, you need to figure out L by K critical ratio, right? By, you need to find L by K critical, then you will know L by critical. If L by K critical is greater less, your L by K is higher than this value, then you will be right side. Then this is long column. You're on the left side, this is short column. Right? We use the, this is the scale, L by K critical. Similarly, if a wall of the pressure vessel is too thick, you might say this is thick wall. No, that also might behave like a thin wall. Similarly, a pressure vessel, very thin, wall is very thin, but depending on size, it might work as a thick wall pressure vessel. So how we'll figure out? So there is a some thumb rule that if a radius of the pressure vessel is Ri, internal radius Ri is greater than 10 T, T is the wall thickness, then this is called thin wall pressure vessel. We'll call it thin wall pressure vessel. But if Ri is less than 10 TW, then we'll call it thick wall pressure vessel. Okay, so those this rule will apply to identify that which pressure vessel is thick and which one is thin. Because thick wall, you have one formula, thin wall, you have one formula. Now, depending on the geometry or size. Pressure vessel might be cylindrical shape. Most of them cylindrical shape, like boiler. We use gas cylinder in our car, in our home, cylindrical shape. Then you see a lot of like Bangladesh Oxygen Limited. They carry the truck, oxygen, liquid or either gaseous oxygen in a cylindrical shape uh, truck, right? Then you see the pressure vessel might be spherical. Spherical mean like football is a pressure vessel. Wall made of leather, but inside has a air and pressurized, right? Similarly, it might be made by a steel plate and inside might be some fluid. Other thing is a hydraulic cylinder. Our piston cylinder is also a pressure vessel. This is the cylinder, and inside the cylinder, your piston is moving up and down, right? So a piston moving up, this portion pressure gradually, piston moving upward, pressure gradually increases. So it is burst. Then what will happen? Engine damage. It will not get any power. So during design the cylinder, you need to make sure that your pressure, your cylinder will not burst due to the pressure. Similarly, hydraulic cylinder. You see a lot of pneumatic system. You see crane. Then you see some equipment like weight lifting crane and also digging, earth digging equipment like Bangla Cat. They import some machineries they use in the construction. They use the pneumatic or hydraulic system to lift something. Okay, so what happened there? You have a tube. Inside the tube, there is a one piston is moving up and down. So say inside right over here is a some fluid in this region. This is moving downward, then pressure right over here will decrease or increase, right? So when pressure increase, you need to make sure it is not burst. Then gun barrel. So how gun work? In our country, we don't use gun, but some other society like Western country, right? They use the gun. How gun work? You have a trigger right over here, right? And in the gun, this is the barrel. You load your bullet right over here, just for a example. And behind this bullet, you made the explosion. So due to high pressure, this travel faster. Okay. But what will happen right over here? Due to increase of pressure, this one might be passed. So you buy a gun with $1,500 or might be $10,000, but you need to make sure you design it, then you made it and put in the market. And if customer buy one time, it is burst, nobody will buy it, right? Other thing you might see, I think now it might be not there. Cannon used to use in Nawab Siraj-Dowla. At that era, in the old era, you might see some cannon in the Gulistan. We see it. Right now, I think they take it out from the Gulistan in the some place. No, that still might be in the museum.
There is one at Jangir.
I think in Shahbag Museum, you might see some water cannon. Some cannon, and this cannon, you see, you look carefully, this is like a crack. Why those crack? While they use, due to the pressure, it got crack over here, crack over here. Okay. So all the gun, barrel, cannon work like a pressure vessel. Then high pressure pipeline, you carrying natural gas from Bakrabad gas field to say Dhaka or from Iran to China. Then in using high pressure pipeline, you need to make sure pipeline is not getting burst. Then submarine, aircraft fuseless. So you need to use the pressure vessel formula. Okay. Now, when you loaded a beam, what kind pressure is there? Stress is there. You loaded a beam. You loaded a beam. There is on stress, bending stress. sigma equal to my by I. What is the other stress? Anyone? Anyone can tell me what is the other stress in beam? Prova, roll on 53. You can tell me, hello, you are there?
Sorry, sir. I forget about it.
No, you should not forget. Okay, there is two stress. Bending stress, I already write down. What is the other stress? Just give me the name.
So shear stress.
Shear stress, good. And this shear stress formula, tau equal to GQ by IB. Similarly, in the column, we have only normal stress, sigma critical, right? So in the pressure vessel, there is a three stress. One is called tangential or hoop stress. One is called radial stress. Other one is called longitudinal stress. So one is tangential or hoop. Other one radial stress, and other one longitudinal stress. So in next class, we'll discuss these two things. Okay, we'll start from here. Now we have 4 minutes, right?
Yes, sir.
I like to discuss something else. What is the difference between bending moment and the torque? Unit of bending moment and unit of torque is same. Newton meter or feet pound is same, right? But due to the bending moment, what happened? Something bend, like a beam bend due to the bending moment. But due to the torsion, what happened? There will be a angular deformation, right? There is a twisting that the material will rotate due to the torque. Then, hello, whose mic? Somebody's mic is getting background noise. Okay, whose mic? And other thing that due to the bending moment, there will be bending stress. What is the formula for the bending stress? Sigma equal to MC over I or MY over I. And due to the torsion, there will be shear stress, tau equal to TC by J, right? And you see shear stress in a shaft at the center is 0, right? But in a beam, you will see shear stress where 0. Outside fiber is 0, but at the neutral axis, shear stress is maximum. So sometime we put short question, what is the difference between beam and the column? Then sometime we put question, what is the difference between bending moment and the torque? Due to moment or difference between moment and torque. Due to moment, material bend, it create bending stress. Due to the torque, material rotate and it create torsional shear stress. Torsional shear stress formula, tau equal to TC by J, but for bending stress formula, sigma equal to MC over I. In torsion, due to the torsion, shear stress at the center of the shaft is 0. But due to the bending, shear stress in a shaft at the center is maximum. Okay. So those difference you need to put in the exam if I put those type of question. So we can stop it here. So far, any question? Any question?
No, sir.
No? No question? Okay.
Sir, what was the RI?
RI is the inner radius of the pressure vessel.
Okay.
It has a thickness, so RI is the inner radius. Okay. What is your ID?
So 139.
139. Okay, thank you.